Hello everyone. This is going to be finding real zeros of polynomials, and I want to stress that this is going to be by hand. So prepare yourself. This is going to be long. This whole video is just going to be me going through a single example. And the speed that I go through it is about the speed that it takes. So finding real zeros of polynomial is just long. It's a process. But after you do it, you'll be really grateful that we have the use of technology. Okay, so that being said, here we go. So the strategy to find real zeros of polynomials. So again, by hand, this is not possible unless a polynomial has integer coefficients and has at least one rational zero. So let's suppose for our sake it does. So the first thing we can do is we can use Descartes' rule to find a bound on the number of positive and negative zeros by checking out the sign changes. Then we can find our first zero using factoring or rational root theorem. So if your polynomial does not factor, you have to use rational root theorem. If it does factor, congratulations, your life is a little easier. After we find our first zero, we can use synthetic division to either find the remaining zeros or to find the remaining factors, depending on how big our polynomial is. And then we kind of just repeat this process until we figure out all of the zeros. So it's like rational root theorem, find a zero, divide. Rational root theorem, find a zero, divide, or solve, depending. And we're kind of just going until we have all the zeros. In general, we would use our graphing calculator or graphing software, but let's pretend we lost everything and are still concerned about finding zeros of polynomial. So again, this is a long, drawn-out, by hand process. Here's our example. Find all real zeros of this polynomial, 3x to the third minus 6x squared minus x plus 2. So I'm going to skip over Descartes for now. We can use Descartes later as an upper bound. If you're not sure, like, are these the zeros, are these not the zeros, you can check yourself by using Descartes. So use rational root theorem to find all possible zeros. So rational root theorem says take all factors of your constant term, so factors of 2, which are 1 and 2 and negative 1 and negative 2, and then take all factors of your leading coefficient, so factors of 3 are going to be 1 and 3, and then negative 1 and negative 3. And then from here, we need to combine them in all possible ways. So possible zeros, then would be, let's see, 1 over 1. So we could have 1 over 1. We could have 1 over negative 1. So that's where the positive negative comes in here. Then 2, we could have 2 over 1, or we could have 2 over negative 1. So that's positive or negative 2. And then we could have negative 1 over 3 or negative 1 over negative 3, which would be positive or negative 1/3. Or we could have negative 2 over 3 or negative 2 over negative 3. So which would end up being just positive or negative 2/3. These are 8 possible zeros. Positive 1, negative 1, positive 2, negative 2, positive 1/3, negative 1/3, positive 2/3, negative 2/3. So 8 possible zeros. So rational root theorem found us 8 of the possible zeros that we could have. So in the next step, we're going to use these possible zeros, we're going to plug them in, and we're going to test to see which one out of the 8 of these we actually want. So step 2, test all your possible zeros by plugging them into your polynomial. Okay, so I'm just going to make this nice little chart. I kind of did this ahead of time, so I have these calculations already. So, but you won't. You will have to do this by hand. Everywhere you see rational root theorem, it's like, oh, here are all your zeros, and oh, we just plugged them all in, and oh, I found that this one worked. It's like, yeah, but behind the scenes was like 15 minutes worth of work. So if our x was negative 2, I already pre-found that we would have negative 44 if we plugged it in. If our x was negative 2/3, I already figured out that we'd have negative 0.89 if we plugged it in. If our x was negative 1/3, we'd get 1.5 if we plugged it in. If our x was positive 1/3, we would get, what did we get, 1.1? 1.1 if we plugged it in. If our x was 2/3, we would get negative 0.44 if we plugged it in. If our x was positive 1, we would get negative 2 if we plugged it in. And then lo and behold, if our x was 2, we would get a 0. Oh, thank everything. We found our 0. So, depending on how lucky you get, the last x you test may be your 0. So in other words, we've gone through 7 tests, and we found it on the last one. So in this case, we have figured out that x equals 2 is 0. So we found our first 0. It's x equals 2. Okay, in the next step, we're going to figure out what we do with this. So, step 3, turn your 0 into a factor and use synthetic division to find other factors of remaining zeros. So we found that x equals 2 is a 0, which implies that x minus 2 is a factor. Okay, if we have one factor, can we find other factors? Yes, we can. We can do it with synthetic division. Okay, so I'm going to divide this now by the factor that I know using synthetic division. So if 2 is my 0, then 2 is my window number. Line up all my coefficients here. So my coefficients will be 3, then negative 6, then negative 1, and then 2. Draw my line. 3 comes straight down. 3 times 2 is 6. Negative 6 plus 6 is 0. 2 times 0 is 0. Negative 1 plus 0 is negative 1. 2 times negative 1 is negative 2. 2 plus negative 2 is 0. So, which is expected because we knew x minus 2 is a factor, so we should not have gotten a remainder. So our next factor is drop the power by 1. So 3x squared plus 0x minus 1 plus 0. So we can clean this up. 3x squared minus 1, which implies that 3x cubed minus 6x squared minus x plus 2 factors into x minus 2, which we got from our rational root theorem, times 3x squared minus 1. Okay, we're almost there. So on to our next step. So solve remaining factors for remaining zeros. So what we have so far, we know that our factors are x minus 2 times 3x squared minus 1. Okay, we also already know that x equals 2 is one of our zeros. So now to find the remaining zeros, well, how do we do that? We're just going to set that guy equal to 0. So how do I solve 3x squared minus 1 equals 0? Well, there's a couple ways we can go about this. This is just a quadratic, so use quadratic formula, use factoring. In this case, we can just straight solve it out by adding 1 to both sides. I get 3x squared equals 1. Let's divide everything by 3. X squared equals 1/3. Let's take the square root of everything. When you take the square root of everything, you need to put a plus or minus out in front. Okay, so we would have plus 1/3 plus the square root of 1/3 and negative square root of 1/3, but now we have to rationalize the denominator. So this is actually plus or minus 1 over root 3 because square root of 1 is 1, square root of 3 is square root of 3. Rationalizing the denominator by multiplying top and bottom by square root of 3 because we cannot have square roots in the denominator. 1 times square root of 3 is square root of 3. The plus and minus is going to come along for the ride. Square root of 3 times square root of 3. This is just simply 3. Okay, so we have found all of our zeros. So zeros of this thing are, we know 2 is a 0. We know positive root 3 over 3 now is a 0. And we know negative root 3 over 3 is also a 0. We have 3 zeros, and this polynomial is to the 3rd power. So we know that actually, in fact, we have found all the zeros because fundamental theorem of algebra says if we take the power, the leading power is the max amount of zeros that we can have. So we found 3 zeros, it's a cubic, so that is all the zeros, so we're good. So this didn't seem like such a long drawn out process when I did it, because back in one of the previous slides I had already pre-calculated all of those rational zeros when I plugged them in, and I already had that ready. So you didn't see the behind the scenes work of me plugging all of those in and figuring out what the answers were to all of them and finding out which one equaled 0. But if you did, this video would be more like 25 minutes long than 11 minutes long. Okay, so just know this is going to take you some time. Okay, this is going to be some work. Plugging in those zeros is going to be the longest part of what you have to do. And also know that this is just basically here for you to appreciate the use of technology that we have now. And we no longer have to do things like this by hand, because thankfully graphing calculators exist. Okay, but it's still useful to figure out how to do this by hand, because doing the hard things appreciates the easy things. Okay, as always, if you have questions, please just ask.